There was some input to the calculation. The input was this and this. This has 3 significant figures, so the accuracy is somewhere over here. This has only 2 significant figures. Okay? Which is the higher error? Which has the higher error of these numbers? This one has higher errors. I don't know what the error is, but I know that this has higher errors because this is not given already. Okay? The result, as I just showed you, the error in the result is going to be the percent error in this, which is like 1 part or 5 parts, whatever. Let's say 1 part in 1,000, plus the percent error in this, which is unknown here. 1 part in 100. So the overall result is, how well do I know this result? What can I believe in this number that came out of your calculator? Well, I can only believe 2 significant figures. The next one is not known. 1% error, right? So this business about what goes in comes out. Believe only the biggest errors in the input. That will be the input. That will be result error. Okay, as percentages means count the significant figures of the input numbers. The smallest number of significant figures is what you believe, even if you don't know the exact error with 5% or 2% or what. But the number of significant figures that you will take in the answer has to be the smallest number, the worst accuracy in the input. So where shall I cut this result? What do I believe? Do I believe the 7? Yes. Do I believe the 3? Yes. Do I believe the 1? No. Maybe it's 2. Okay? How come the calculator gives you this? Because the calculator doesn't know what you are doing this for. It doesn't know what you believe. It has a certain built-in program, and the program just puts lots of zeros after all of these numbers and makes the division accordingly, as if these numbers were, had 8 zeros after them, and gives you a result which also has 8 digits after the point. But that's just a computer program there. You didn't put that program. There's no reason why you should believe the results that appear more accurately than your input. All right? Of course, the general rule is not 2 significant figures. This is the worst, smallest number of significant figures in the input. Okay. There are more examples of this in your book. You can make up some more examples. We discussed in the recitations this week. So just get this straight. Never give us any answer that is more accurate than the input. In the labs, if you give 8-figure accuracy results, 1 point off. Okay, don't do this. Now, not finished yet. We have 5 minutes, and I will introduce something. I'll use L for length, T for time, M for mass. Suppose I have the following problem. Simple problem. I'm driving a car and I decide to stop. I'm going at 100 kilometers per hour, let's say. And I start applying the brake. And my car is giving a constant braking, constant acceleration. So the speed is going to become slower and slower every moment because I have my foot on the brake. So the problem gives me, okay, my initial speed is 100 kilometers per hour, and when I brake, the brake discs apply a deceleration, stopping acceleration of so much, I don't know what, okay? How many meters will it take before I can stop? Some acceleration A, meters per second square. That's the unit of acceleration. How much velocity changes per second? We'll check about the unit later, okay? I'm assuming you don't know anything, it's just a problem. Okay? And stops in h meters. How is VAH, how R? So I have an initial velocity, and the distance that I stop will depend on this initial velocity, of course, and it will depend on the brakes. So the velocity, initial velocity, will be related to this acceleration, and how many meters I go before the car completely stops. I don't know how, I'm trying to find the formula. Let me try that this velocity depends on some power of the acceleration. And I'm trying to see if such a formula will work. Okay? Velocity, initial velocity, depends on acceleration and the stopping distance, and suppose it depends on certain powers. And I want to figure these powers out. Now, this is what dimensional analysis does. Dimensions of V are written like these square brackets. It means what kinds of units does velocity have? Well, velocity is length over time. It doesn't even matter which unit I use, centimeters or meters or seconds or hours or whatever, but velocity is going to be some length divided by some time. So this, here is a bit of mathematical language. Dimensions of velocity, I just say square brackets. This means what are dimensions of velocity, okay? And when I put an equality with 3 lines like this, it means definition. So you don't ask why, this is just a definition. Okay? Clear? Now, the dimensions of acceleration is, well, it's how much velocity you change per second. So it's L over T squared. Does everybody understand this? No. Okay. Acceleration, we didn't learn acceleration yet. I'm just giving an example, right? Acceleration is how much change in velocity you make per second. Because in this example, how far the car will drag on before stopping will depend on how strong your brakes are. And that's the acceleration. And what do the brakes do? It changes your velocity from 100 kilometers per hour to 90 kilometers to 50 kilometers and eventually to 0. In each second, how much is the change? So kilometers per hour or per second. So it's L over T divided by another T. So L divided by 2 T's. That's what dimension means. Okay? So this is the dimension of acceleration. Okay? And what is the dimension of... Okay, now let's use this formula. Not use the formula, I'm checking the formula. I'm trying to figure out what kind of formula is right. Okay, so I say L over T, the velocity, this is the velocity, equals L over T squared, and I have some unknown power of this alpha, times h, the distance the car goes. What's the dimension of that? Just that, right? Does anybody understand it so far? I don't know what the formula is. I'm trying to figure out what the formula is. And I'm saying that the velocity is going to be, maybe it is, I don't know if it will work. Maybe the velocity will be some power of length, the distance I go, times some power of acceleration. Because those are the only given things in the problem. Okay? So I'm just completely guessing. I'm not even using units, I'm just putting how many L's, how many T's. Now, what does that say? L times T to the power minus 1 equals L to the power alpha, L to the power beta, T to the power minus 2 alpha. Right? Does everybody get this one? What this tells me is